called this lecture series of Automata Theory and Compiler Design. In today's lecture, we are going to see about how to eliminate what is the left factoring and what is the left recursive grammar, and how to eliminate the left factoring and left recursive of the grammar to construct the parser. So in the previous lecture we are know about what is the parser, what is the function of parser means it convert our tokens into the parse tree using the CFG. So using whenever our grammar CFG should be the should not be the left recursive, and it should not be the left factoring, and it should not be the ambiguous. These three statements should be considered when you are deriving a parse tree from the grammar. If it is, means we have to remove it before constructing the parser. The last video we have seen what is the derivations and what is the parse tree, and in today's video we are going to see about what is the left factoring. So left factoring means in the grammar we have a production. For example, A tends to A or B means you have two alternative derivations for the given left hand side non-terminals. So when you are going to derive that, either first we are the parser take it as a alternative A to deriving to replacing a non-terminal A to small a. Suppose that input string is not derived means it is backtracking, so it move to find out the other alternative to deriving the input string. So this alternative, so these two backtracking, to avoid that backtracking we go to left factor out our grammar. So what is the left factoring means? Removing the common left factor that appears in two productions of the same non-terminals. So removing the common left factor that appears in the two productions for a single non-terminals. So eliminating the left factoring helps in avoiding a backtracking. For example, consider the grammar A tends to QB and QC. But our string should could be that QB means two first symbol is common. So we have to factor out the common thing from the two productions for the same non-terminals using the rule. So what is the rule means? For example, A tends to QB QC means so the A dash tends to the A tends to A dash, then B or C. So what is the A dash? A dash is the A dash tends to Q A dash. So the A dash or B or C. Here A is equal to QD and D is equal to B or C. So for example, நம்ம என்ன பண்ணுறோம்னா அந்த காமன் ஃபேக்டரை வெளியே எடுத்துட்டு ரிமைனிங் இருக்கிற அந்த பிஆர்சிக்கு எனி வேல்யூ we can substitute. For example, A tends to Q A dash means we have to derive what is the A dash. A dash is nothing but it is a BRC. So this is the rule to eliminate our common factor in the two productions for the same non-terminals. So that could be eliminated. Next is the left recursive grammar. So what is the left recursive? That means the leftmost non-terminal in a production is the again the same non-terminal means it is a left recursive grammar. For example, A tends to A alpha. In that the leftmost non-terminal is appeared immediately the leftmost in the right hand side production means that is grammar is called it as a left recursive. So we have to eliminate the left recursive in the grammar also. So what is the rule to eliminate means? Suppose you have a production A tends to A alpha or beta. Okay, so that could be derived by A tends to beta A dash. Okay, so A dash tends to beta A dash. The A dash tends to, what is an A dash? It is an alpha A dash or epsilon. So this is the rule you have to find out. So A tends to A alpha or beta அப்படின்னா beta A dash எழுதுறோம். What is an A dash அப்படிங்கிறது alpha A dash or epsilon. That is that rule we have to find out. For example, you have a grammar E tends to E plus T or T. So that could be rewrite as E tends to T E dash. Okay, அப்போ E dash என்ன அப்படின்னா alpha. Here alpha is plus T. So plus T E dash or epsilon. So alpha is equal to plus T and betaங்கிறது T. இதை வச்சுட்டு we have to match with our rule and we have to derive. Again another example is, for example, you are having a T tends to T star F or F. So what is a left recursive grammar? The immediate left hand side non-terminal is appeared, right hand side production left to most means that is a left recursive. Why we have to remove means we are going to recursively call the same procedure again and again. So that leads to the complex problem. So to eliminate that immediate left non-terminal, we are using the rule of A tends to A alpha or beta or formula irundhuchina, that could be rewrite as A tends to beta A dash and A dash tends to alpha A dash or epsilon. So this is the two terms we have to consider for constructing any parser. Suppose we have to construct any top down parser means the top down parser construction, first we have to check our grammar is ambiguous. Ambiguous grammar means that derive single using a single production, single grammar for a given input string we can derive more than two parse string means that is an ambiguous. Okay, that could be eliminated. Second one is left factoring. So for the two productions we have to common factor should be left out to produces the parse tree. So that left factoring also to be done. Next is the left recursive to be eliminated. So the grammar is check whether the given grammar is left recursive means that it also be eliminated for constructing the parser. That is a top down parser. Thank you.